Okay. Hello, everyone. So I'm just making this recording on how to answer some of those questions, those word problem questions that I signed last Friday. Okay, so this is the problem we worked on last Friday. I'm just going to solve it straight through. So this says last weekend, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one in three ways. So you have three options. A senior admission ticket costs $5. Child admission is $6 all day, and the regular admissions are $8.50. How many of each type of ticket was sold if twice as many child tickets were sold as seniors? Okay, so just like in class, we have this annotated using cubes. So we're circling the important numbers and we're boxing the key terms and we're underlining the questions. So that's how you want to start off with this type of problem. Next, you want to just organize the type of information you're given. So if we see here the dollar signs, that all represents cost, right? So let's have that in green. No, let's have that in purple, right? Okay, so all right, so we have $5. That's the price of a. Okay, so actually, let's try to figure this out. How many of each type of ticket was sold? Right? So we're trying to find the number of tickets. From that information, we need to find the number of tickets. So the things that we don't know, the ones that we're trying to find out, we're going to give them variables. So I have S for number of senior tickets. Then I have C for number of child tickets. And then I have R for number of regular tickets. I think we used A in the class. So now that I have all my variables named out, I can go ahead and look at the other information. So it says here we have 850 movie tickets. So notice how this one doesn't have a dollar sign. So this is just talking about the number, total number of tickets sold. Total number of tickets. So that means child tickets, senior tickets, regular tickets, and you put them all together, you have 8,500. And then on the flip side, right over here, we have all these dollar signs. That represents the cost. So we know that the $5, it goes with the senior admission. So if I want to find the total the total cost of all the senior tickets, I would need to do 5, so $5 times each of the number of tickets. I don't know that, so I'm going to use my variable S. So that's the total cost of senior tickets. Okay, and then next we have 850. I'm sorry, next we have $6. That's going to represent the cost of one child ticket. Now, if I wanted to go ahead and try to answer this problem right over here, um, if I want to find the total cost of child tickets, right, I would need to multiply this price by the number of child tickets, which we don't know, so we called it C. And then we have 850. So $8.50 is the cost of each regular ticket. We don't know the number of regular tickets, so we're just going to call it R. So this will be 850R. It's as if you're multiplying right over here. Okay, so let me just go ahead. All right, and then we have 64,600. That's proceeds total. So whenever you see proceeds, that's like total that's the amount of money, the amount of sales they made. So if I add up all these total prices, total costs, oh, sorry, total like earnings, right? I would get $64,600. Okay, so I have all my information settled. I have my numbers on this side. I have my money in purple on the other side. And now I need to go ahead and move on to make my equations. So if you notice in the question over here, it says twice as many child tickets were sold as senior tickets. So this one is a hint that we have a, what's that called again? A expression. So it says twice as many child tickets were sold as senior tickets. So that's a hint to us that child tickets is actually more than the senior tickets. So we need to twice as much, that's 2 times S. So that's how you translate twice as many tickets as were sold as senior tickets. Next, we have to pretty much use the information given to write the other expressions. So you notice here with the numbers, right? If I put all these numbers together, I would get 8,500. So what's the what operation it means put all together? That would be addition. So I'm going to add S, C, and R, all those numbers, and it'll give me 8,500. And that's my second equation. My third equation has to do with the prices. So I have all three of these. If I added them all together, I would get 64,600. 5S plus 6C plus 850R is equal to 64,600. Okay, so now we have all three of these equations we can work with, right? And we know how to solve these. We use systems of equations. Sorry, yes, so you can use either substitution or elimination. Now, this one right over here, since you have that C by itself, we can actually use substitution first. So this over here, this is number one is a little hint to me that I need to go ahead and use substitution. Okay, so what that means is that wherever I see the letter C, the variable, I need to write 2S. So for the second one, instead of writing C, I'll write 2S plus R is equal to 8,500, right? And I just want to go ahead and simplify this. So I have my like terms, the S and 2S, that makes 3S, plus R is equal to 8,500. So look at that. I was able to break down this three variable equation into just two variable. Now I'm going to do the same thing with the second equation. So, sorry, with the third one. So if you look right over here, we have 5s plus 6c is equal to plus 850r is equal to 64,600. So on this side, right? Again, wherever I see the letter C, I'm just going to write 2s plus 850r is equal to 64,600. And again, you just want to go ahead and simplify this. So 6 times 2, that's 12. So let me just bring down the 5s, 12s, 850r, 64,600. I just want to go ahead and add my like terms. So this is 17s plus 850r is equal to 64,600. Okay, so again, in my third equation, I took a three variable equation and then I just broke it down into just two. So now I can actually see if I can try to take away even more. So let's first put them underneath each other. So we have 3s plus r is equal to 8,500. And then we have 17s plus 850 R is equal to 64,600. All right, so there's a couple of ways we can go ahead and tackle something like this. We can use elimination, or you can use substitution. A number of you said that you feel comfortable with substitution. So let's look at that. The first equation, you see R is by itself, right? And it's a positive 1 in front. So it'll be easy for us to get to turn this whole equation in terms of R. So, oh, this is an S. So I'm going to subtract S on both sides. And you're going to get R is equal to 8,500 minus 3S. So now I made another code. Wherever you see R, you want to put in this expression. So I'm going to place this over here just to connect the two equations. So we have 17S plus 850 times 8,500 minus 3S, that's an S, is equal to 64,600. And then here, in this case, I just want to go ahead and start distributing that $8.50. So remember, when you're distributing, you're actually using multiplication, right? So you're distributing here and there. So you have 17S plus $8.50 times 8,500. That gives you 72,250. Then you're doing 850 times negative 3S. And you have minus 25.5S. And you would still have that 64,600. Okay, at this point, you want to go ahead and combine like terms. So some like terms we can see over here is the 17S and the negative 25.5S. So if you combine those two together, so 17 minus 25.5S, this would give you a negative 8.5S, right? And then let me just bring down the 72,000 just to keep everything, what's that called again? Um, you know, balanced. I'm just going to move this second question. Okay. All right, so here you see that 17,000. So you just want to move that 72,000 to the other side because I want to get the S variable by itself. That crosses off. You have negative 8.5S is equal to 64,600 minus 72,250. And that equals negative 7,650, right? So all we need to do right now, we have a negative 8.5S. We just need to divide both sides by negative 8.5. And your answer is going to be 900. So we have 900 senior tickets. And now that we have S, this is our key right over here. Now that we have this, we can go ahead to our original 3 equations and start plotting them in. So let's just recap, right? We just found that S is equal to 900. So we can plug this into this right over here, this question. So we can find the child tickets if we do 2 times S, which is 2 times 900, which will give you 1,800. So the child tickets was 1,800. And then we want to find the regular tickets, right? So we can place this number and this number into into this equation to find that number of regular tickets. So let's rewrite that second equation. S plus C plus R is equal to 8,500. You want to change the S into 900, the C into 1,800, and you want to leave the R alone because that's the one we're trying to find. Notice how when I'm trying to solve things, I just want to have one variable. Having that one variable there left makes it easier for us to solve. So then this will give us 2,700 plus R is equal to 8,500. We just have to subtract 2,700 on both sides. And then your R, the regular tickets, would be 8,500 minus 2,700, 5,800. Okay, so this is the answer to all our okay, wait a sec. Let me just go ahead and box everything here, or at least highlight them. So this is one of our answer. This is another answer, and this over here is our third answer. So we can say over here, they sold 900 senior tickets, 1,800 child tickets, and 5,800 regular tickets. So let's write that over here. Or not. Oh, here you go. So they sold 900 senior tickets, 1,800 child tickets, and 5,800 regular tickets. If we want to put a sentence in. Let's just make it this a little bigger. Okay, so that's the answer to this question we did in class. So it took a while, but we were able to finally find that answer. Now let's look at this second question over here. This one comes from your homework questions. So we have 3 orders are placed at a pizza shop. 2 small pizzas, a liter of soda, and